Hello students, I am Silas Prajapati. Today I invite to you in the chapter number 4, determinants in the last part. Yes students, in this part, the last part, today we going ahead some equations given in the variable x and y and using matrix multiplications and check about first of all consistency, and after that we will derive for the value for x and y by the matrix multiplication using. So let the first explain about 4.6 first one. Examine the consistency. Consistency means both line intersect at a one common point. It means common point. That type of question already we studied in the 10th standard, elimination method, substitutions method. That topic is again coming here. But we go to by the method of matrix. So first of all, given two equations, we express in the matrix multiplication form. We express both equation in matrix multiplication form. Multiplication form, if you write down, then here one of the matrix form that like just here these 2 3 we slot that. Similarly here x were right and here the numbers right only 1 2 2 3 1 2 2 3 and go to just a x and b. So definitely a into x is a b. So x is equal to b by, you know that a inverse into b, and when a inverse exists, yes, determinant a non-zero. So first of all you check determinant a. We'll do 1 2 2 3, it is -1. Therefore we can say a inverse and unique solution is exist. If you a modulus say 0 coming, then not exist. So here unique solution exists, so it is a consistent equation. Therefore both equation 1 and 2 are the consistency. Yes, are consistence. Just you can write down in consistency. And if u equal to 0 coming, then not consistent. Similarly, we express in the matrix form. Just write the statement as above. Here 5 4, and that is consider a x b. So definitely a into x is equal to b. We can do x is equal to b by a, which is a inverse into b. So just go to determinant a. 2 1 -1 1, 2 plus 1 3, non-zero. It means answer is unique solution exists and it is a consistency. Therefore a inverse and unique solution is exist. So both equation 1 and 2 are, definitely we can write down it is consistency, are consistency. Now going same third one, same statement, right? We express both matrix multiplications in the form. So here 1 2 3 6 xy and is equal to 5 8. That's become a x and here b, and go to simple form. Our answer is a into x is equal to b. So x become b by, definitely we can say a inverse into b, and that's your converting to a inverse. So I just go to determinants a. 1 2 3 6, it is 0. It is not consistent. Unique solution not exist and a inverse also not exist. So you can say here a inverse and unique solution does not exist. So therefore equation 1 and 2 means these two are not consistent. Yes, that become you finally write down your answer. It is not consistency. Because of that, determinant A is 0. Now continue. Question number 4. Same process. Going ahead in the fourth one. It means inconsistent, or not consistent, either inconsistent. Both are word same. Now 3 equation given. X plus y plus z 1. 2x plus 3y plus 2z 2. And ax plus ay plus twice az. Statement 1. Statement 2. Statement 3. X plus y plus z1, 2x plus 3y plus 2z2, ax plus ay plus 2az is equal to 4. So this equation same represent. It is converting into matrix multiplications. 1, 2, 4. X, y, z. And here 1 to a, 1 3a, 1 to 2a. And going to a, x, and here b. Definitely you can again show same process. It is b by a, just a inverse into b, and here students operate. A inverse means determinant say I calculate 0 or not. So determinant A I have just 1 2 a, 1 3 a, and 1 2 2a. Just show out the calculations. So 6a minus 2a, 4a. 6a minus 2a. Next 4 minus 2, 2a. And last 2a minus 3a, minus a. So 4a minus 3a become a. But non-zero. It means it is a consistency. Yes. So equation 1, 2, 3 are consistent. In short, these all 3 lines intersect at one common point. Either you can say also this word is a concurrent lines, and this point, common point, is called concurrent point. Yes students, therefore it is saying that it is a consistency. Next, question 5. Same. Similarly, just equation is changed here. In fifth, 3x minus y minus 2z is equal to 2. This is IM here. 3x minus y minus 2z is 2. Now here 2y minus z minus 1. 3x minus 5y 3. Students, just to check, 3x minus y minus 2z 2, 2x by 2y minus z, and 3x minus 5y. Students, here one data is missing given. Here no given, so that's why I write down 0x. And here no given, so it is a 0z. So express in matrix multiplications form. So you have to here 3 0 3, minus 1 2 minus 5, and minus 2 minus 1 0. That xyz. And here 2 minus 1 3. Same way, this consider to a, here x, and here b. That's why a into x is equal to b. So definitely x is equal to b by a. It is a inverse into b. Now we converting a inverse in determinant a. So students, your determinant a, just I check 3 0 3, minus 1 2 minus 5, and minus 2 minus 1 0, and going to solution. So 3 I have, plus 1 I have, and minus 2 I have. So first of all 0 0 minus 5, middle order 0 plus 3, and last 0 minus 6. So minus 15 plus 3 plus 12. Oh, it is 0 coming. So inconsistency, yes. Therefore, first equation, second and third are inconsistent, either not consistent. It means these three lines are not intersect at the one unique point, that is first, second and third. Again repeat, these three lines are not intersect at a common point. Now sixth, same moving. Equation 3 similarly given. 5x minus y plus 4z is 5. 2x plus 3y plus 5z is 2. And 5x minus 2y plus 6z. 5x minus y plus 4z is equal to 5. 2x plus 3y plus 5z is equal to 2. And 5x minus 2y plus 6z is equal to minus 1. Students, here also represent in the matrix multiplication form. So you go to first matrix with second is equal to here 5 2 minus 1. That become xyz. And here 5 to 5. Next minus 1 3 minus 2 minus 1 3 minus 2, and last 4 5 and 6. So going to same a x here b. In short, a into x b. So x become b by a. So a inverse into b. And now determinant a I just check out. 5 to 5 minus 1 3 minus 2 and 4 5 6. Students, just here calculate 5 plus 1 and plus 4. 5 plus 1 and plus 4. Students, just I calculate and check about determinant A is 0 or non-zero. Here if you 5 going, then 6 3 is 18 plus 10. 6 3 is 18 and 5 2 is 10. Next, students, 6 2 is 12 minus 25. And last minus 4. 2 2 is 4 and 5 3 is 15. So here 28 5 is plus here minus 13. And here students minus 19. 28 5 is 140 minus 13, and here 9 4 is 36, 3 carry 76. Answer is definitely never 0. So 140. Here 6 and 3 9, 7 and 1 8, 89. 89 and 40. So 140 minus 89. Just here do 3 and 10. It is a 1 and 5, 51. 9 minus 9 is 51. Yes. But definitely non-zero. Yes, 9 and 1 10, 1 carry, 8 and 5 14, 15 14. Students, finally this answer is a consistency. Because of that, determinant A is a non-zero. So you can say given 3 equations are inconsistency. Consistency also write down, don't worry, a consistency they are the same as. Now question 7th, students, and now after that find out the solution also. Equation, linear equation using matrix method, solve the equations. It means consistency necessary check, and after that we will do solutions. That also very easy. Write the question number 7. Solve by matrix multiplications. 5x plus 3y, 5x plus 2y is a 4, and 7x plus 3y is a 5. Statement 1, statement 2. Again 5x plus 2y is 4 and 7x plus 3y is 5. Simple. Just I go to matrix converting form. So first of all you write down both equation 1 and 2 expressed in matrix multiplication form. That you necessary, students, first of all show. So my first equations into is equal to answer. Here 4 5, it will be to xy 5 7 and 2 3. So here it is matrix A, here x and here B. So definitely A into x is B. So I just show x is equal to b by a. It means a inverse into b, and that value now I converting into finally a inverse is a 1 upon determinant a into adjoint of a. So I start my determinant a first. 5, 7, 2, 3. So 5 3 is a 15, 7 2 is a 14, 1 but never 0. In short, a inverse and unique solution is exist. In short, it is a consistency. Yes, a unique solution is exist. So I will do adjoint of a. Adjoint of a known very well. These are the principal diagonals. Interchange their place. Secondary diagonal, symbol change. So 3 5 exchange, minus 7 minus 2. And finally you can go to in this equations. So x is equal to now a inverse into b, but a inverse I know. X also known xy. It is 1 by determinant a adjoint of a into b. The same determinant a is I have to known, that is 1. Adjoint of a also known, it is a 3 minus 7 minus 2 5. And B matrix, students, this is your known. B matrix is a 4 5. Now this row, this column, yes, 4 5, just matrix multiply apply. So xy same. Here 4 3 is a 12, 5 2 is a 10, 7 4 is a 28 plus 25, 7 4 is a 28 and 5 5 is a 25. So you have finally done xy. Here 2 minus 3. In short, your solution is ready. X2 and y minus 3. Very easily and very happily, students answer is done. 2 comma minus 3. Now 8. Eighth also in same process. Solve the equations by the given. My given equation is 2x minus y is equal to minus 2 and 3x plus 4y is equal to 3. 2x minus y is equal to minus 2 and 3x plus 4y is equal to 3. So does equation same, right? Both equations 1 and 2 express in the matrix multiplication form. Matrix multiplication form. So you write down first matrix here 2 3 minus 1 4. Next here xy, just you can check that is your product value and is equal to minus 2 and 3. So students, that is your A, it is x and that is the B assumption. So definitely A into x is equal to B. X is a B by A, it is A inverse into B, and A inverse also known 1 upon determinant A adjoint of A into B. In short, I calculate determinant A and adjoint A. Determinant A I have 2 3 minus 1 4. So 4 to the 8 plus 3 11 known 0. It means A inverse and a unique solution is exist. Now if you exist, then adjoint define and calculations. So students, here I go to adjoint of A. My adjoint is ready. Principal diagonal both are interchange 4 2. Secondary diagonal symbol change, here 4 to exchange, here minus 3 and plus 1. Now finally I will do my answers in the solutions. So it should be now x is equal to 1 upon determinant A into adjoint of A into B. X I have simple xy. Determinant A is 11 only. Adjoint of A is a 4 1 minus 3 2. 4 1 minus 3 2. And B also known, students. I have just minus 2 with 3. So here row, entry, column, matrix multiply. Xy same, 1 by 11, here minus 8 plus 3, 6 plus 6. So students, you will go to finally your answers very easily. After that I will go to my final solutions. Now students, after all we will get 1 by 11, here minus 5 and here 12, and so finally you getting your answer minus 5 by 11 by 12 by 11. So your solution is finally done. X become minus 5 by 11 and y become 12 by 11. That's your simple answer. I just check my answers. Question number our 8th one. Yes, minus 5 by 11 and 12 by 11. Continue going. Question number 9. 9 also same question, students, only these are equations is change. My data is a 4x plus 3y minus 4x minus 3y is equal to 3 and 3x minus 5y. 4x minus 3y is 3 and 3x minus 5y is equal to 7. Students, here are same calculations. Just I write down my little equations, matrix converting. These are equations similarly. These are similarly, only this change and this change. So matrix multiplication same as write down here 3 7, here 4 3, minus 3 minus 5, and now determinants 4 3 minus 3 minus 5. So 5 4 is 20 plus 9 minus 11 non-zero. So A inverse and unique solution exists. Now adjoint of A, principal diagonal, interchange, minus 5 and 4. Now students, secondary diagonals, you just symbol change, minus 3 and 3. So after we'll go to solutions. So x is equal to A into 1 upon determinant A, adjoint of A, and these are similarly, I just write my formula. So 1 upon determinant A will do 1 by 11 minus adjoint of A, minus 5 minus 3 3 4, and B, matrix B is a 3 and 7. So students, row to column, you can show your entry. So my answer is 1 by minus 11 minus 15, 7 3 is a 21, minus 9, 7 4 is a 28. So xy here 21 minus 15 is 6, and here 28 minus 9 is 19. Yes. So final answer is a minus 6 by 11 and 19 by 11. So I will write my answer solution. X is a minus 6 by 11 and y is a 19 by 11. It's very easy sum. Yes, I also check my answers. Yes, it is a correct minus 6 and the minus 19 answers. Yes, here are minus 19. By mistakes I write down. Yeah. Sorry students. Now continue question number our 10th one. Also same pattern. Only these equations is change. This similarly mentions that change and only this change. Otherwise all are same as write down. So I only rough about it. Calculations part. Question number 10. Solve the equations 5x plus 2y is 3. 5x plus 2y is 3 and 3x plus 2y is 5. 3x plus 2y is equal to 5. Now apply the values. Two equations represent in the matrix multiplications form. First of all, here 5 3 and 2 2. Same as here 3 5. These other are same. Determinant A 5 3 2 2. 5 2 is 10. 3 to the 6, we'll do 4, non-zero. So A inverse and unique solutions exist. Now adjoint of A, only this principal diagonal interchange. Here 2, that 5. 2, 5 interchange in the 5, 2. And minus 3, minus 2. Students, as it is, minus 3, minus 2. Now go to final answer data. And easily you can derive your answers. So here 10 minus 6, 4, and here 1 upon determinant A is 4. Adjoint of A also ready. 2 minus 3 minus 2, 5, and B matrix is 3, 5. Now students, row to column entry. I just made the answers. So 1 by 4. Here 6 minus 10 minus 9 plus 25. So 1 by 4 is as it is, students. Here a minus 4 and here 16 divided by 4. That is minus 1, but here 4. So solution X is minus 1, Y is 4. So my answer is minus 1 comma 4 is truly right. Now 11th questions is a very most IMP, exam oriented IMP questions. Question number 11th. IMP for exam. 2x plus y plus z is equal to 1. Statement 1. 2x plus y plus z. Second given x minus 2y minus z is equal to 3 by 2. But students, you take the LCMs and just you rearrange. So here 2x minus 4y minus 2z is equal to 3. Statement 2. 2x minus 4y minus 2z. And third one, 3y minus 5z. 3y minus 5z is equal to 9. That also I represent in the 0x plus 3y minus 5z is equal to 9. Yes. And now this whole equations represent the equation number 3 in the matrix multiplication. Equation number 1, 2 and 3 express in the matrix multiplication. Matrix multiplication form. So my first matrix parts into second is equal to right hand side. Here x, y, z fix. Your right hand side here 1, that is 3, and here students 9. Now very carefully this coefficient write down. 2, 1, 1. Secondly 2 minus 4, 2 minus 4 minus 2, and the last 0, 3 minus 5. 0, 3 and minus 5. Now go to matrix ED presentations. That is A matrix, it is X, and here B. So students, A into X is equal to B. So X is equal to B by, will do A inverse into B. So my process starts. A inverse process, determinant A, adjoint A. So determinant A here 2, 1, 1, 2 minus 4 minus 2, and 0, 3 minus 5. 2, 1, 1, 2 minus 4 minus 2, 0, 3 minus 5. And students, calculate. You simple answer. 5 4s are 20. 20 plus 6, 26. Again 5 4s are 20. 20 plus 6, 26. Next we will do minus 10, 0. But minus 10 here. And last of this 6 plus 0, 6. So it is 52 plus 10 plus 6. So final answer, it is 58 plus 10, 68. Non-zero. Means the solution exists. So my final answer we will write in the equation. Therefore A inverse and unique solution is exist. So now I go to adjoint of A. So does adjoint of A is a transpose of all cofactors, but this cofactor I will do in the shortcutly. Only this shortcutly I will show the answers. First coefficients, row wise, row 1 first coefficient already I calculate here, 26. Next minus 10, next 6. Now secondly, this and that, minus 5, minus 3, minus 8. Again I check. This and that, minus 5, minus 3, minus 8. Middle order is a minus 10 with 0. So minus 10. Third order, 3 to the 6. 6 minus 0, it is 6. Now L shape, this L shape, this and that. So minus 2 plus 4, again minus 2 plus 4, which is 2. Now next, this T shapes, that and this, minus 4, minus 2, minus 6. Again minus 2 minus, by mistakes I written minus 6, this and this, minus 4, minus 4, minus 2, minus 6. And last, this and this shape, minus 8, minus 2, minus 10. And that the transpose, 26, 10, 6, 8, minus 10, minus 6, 2, 6, minus 10. And that will be, students, going to answers part. Therefore x is equal to A inverse into B, it is xyz, 1 by determinant A, adjoint of A into B. But students, my determinant A is this one, already I known that 68. Adjoint of A also ready, 26, 8 2, 10, minus 10, 6, 6 minus 6, minus 10. And B value is this, students, 139. 139. Now go to matrix multiply. 1 by 68. Here apply to row with column entry. So 26, 8 3s are 24, 9 2s are 18. Next 10 1s are 10, minus 30, 9 6s are 54. And next 6 1s are 6, minus 18 and minus 19. So finally done, 1 by 68, and that is the addition, 20, 20, 40, 50, 60 and 68. It is a 34. 54 and 10, 64. 64 minus 30. Yes, 64 minus 30 will do 34. And last of the minus 12 minus 90. It is a 102 divided by 68. So it is 1 it is half, and that is minus 3 by 2. 34 2s and 34 3s. 34 3s, it is 108. Yes, students, your answer is minus 3 by 2. 1.5 is correct. So last write down. Therefore solution, x is a 1, y is a half, and z is a minus 3 by 2. Now students, afterward question number 11, 12, 13 and 14. Question number 12, 13, 14. You will do itself. So I will do taking the homework. Yes, students, question number 12, 13, 14 is the same pattern. Homework you will try. Question number 12, 13 and 14. I will go to 15th one and 16th one. 15th also. Students, it is a very simple sum. That's why I give you. Same content. If A matrix 2, minus 3, 5, 3, 2, minus 4, and 1, 1, minus 2. 2 minus 3, 5, 3, 2, minus 4, 1, 1, minus 2. Find A inverse. And using A inverse, solve the system of equations 2x minus 3y plus 5z is 11. 3x plus 2y minus 4z minus 5, and x plus y minus 2z is minus 3. Again I check. 2x minus 3y plus 5z 11, 3x 2y minus 4z minus 5, and x plus y minus 2z minus 3. First of all, I calculate A inverse. So process you known very well. Do the determinant as it is. 2 3 1 minus 3 2 1, 5 minus 4 minus 2. In the determinant form, 2 plus 3 plus 5 minus 4 plus 4 minus 4 plus 4. Secondly, minus 6 plus 4, and last t form here 3 minus 2 minus 6 plus 4. Last 3 minus 2 will do 0 minus 2 and here 1. So 0 minus 6 plus 5. So A inverse is exist. It means it is a consistence. Now I will start my adjoint forming. Similarly, going students, pattern is same. We going ahead the parts of adjoint. Therefore, adjoint of A is a transpose of this level 4 values. These are the missing. But first row cofactor already you declare that here 0, minus 2 and 1. Again 0, minus 2 and 1. So the second level, this and that, it is 6 minus 5, 1. Again 6 minus 5, 1. Second middle order, minus 4 minus 5 minus 9, minus 4 minus 5 minus 9. Now this one, 2 plus 3, 5. Now corner, this one corner means this one. Fourth is a 12, 12 minus 10, 2. Now this T shape students, this one and this one, minus 8, 4 to the 8, minus 8 minus 15, minus 23. Again repeat, this and this, minus 8 minus 15, 15 and 8 minus 23. And last corner place this L shapes, 2 to the 4, 4 plus 9, 13. Now we'll do to transpose it. Simple transpose you know, 0, 2, 1, minus 1, minus 9, minus 5, 2, 23, 13, 2, 23, 13. Now finally you can attach the A inverse. Therefore students, A inverse is 1 upon determinant A adjoint of A. What's my determinant A? Minus 1. And adjoint A, 0 to 1, minus 1, minus 9, minus 5, 2, 23, 13. And that's your values to A inverse. I just check my answers. 0, 1, minus 2. Yes, minus 2, 9, minus 23, just minus multiply inside. So here also I multiply minus 0, minus 2, minus 1, 1, 9, 5, and minus 2, minus 23, minus 13. Yes, minus 2, minus 23, minus 13. Now using these equations I will show my solutions. So equation 1, equation 2 and equation 3. So equation number 1, 2 and 3 are expressed in the matrix multiplication. So matrix multiplication form you represent, you know that this first, this second and is equal to last. So my last equation is this one, 11 minus 5 minus 3 xyz, and here write down the our simple cofactors 2, 3, 1, next minus 3 2 1 minus 3 2 1 and last 5 minus 4 minus 2, again 2 minus 3 5, 3 2 minus 4 and 1 1 minus 2. So this is indirectly it is your given matrix A. So I just consider it as a position A, that is X, that is B. So A into X is B. X is equal to B by A. It is A inverse into B. And A inverse B also you know that 1 upon determinant A into adjoint of A into B. Now full value 1 by 1 I apply on it. A inverse fully you know, just you apply inside the X is XYZ officially. 1 upon determinant A adjoint A only fully I calculate. It is 0 minus 2 minus 1 195 again 0 minus 2 minus 1 195 and last minus 2 minus 23 minus 13. And students B is also known 11 minus 5 minus 3. Now finally you can decide your answer, correct answer, that XYZ. Here students row wise you column entry. Simple multiply 0 into 11 0 minus 5 plus 6. Now 11 2s are minus 22 minus 45 minus 45 and last 23 3s are yes at a 69 and last 11 ones are minus 11 minus 25 plus 39. So students your data is known, simple calculation, it is ones are here. I just one more time revise my solutions. 11 2s are minus 22 minus 45 23 3s are plus 69. It is 67 minus, but it is my answer is 2 and that is 3 because here minus 36 plus 39. So my solution finally done 1 2 and 3. Now students one word problem coming here, question number 16, and very interesting questions. Three items given, onion, wheat and rice, and asking that price the each item per kg by the using matrix multiplications. So I will show. Suppose price of 1 kg, first given onion X rupees, next price of 1 kg wheat and second given rice Y rupees and 1 kg here rice, it is Z rupees. This is the suggestions. Now 4 kg onion, 3 kg wheat and 2 kg rice is total given 60. So 4 kg onion means 4x, 3 kg white is 3y and 2 kg rice 2z, 4, 3 and 2 will do 60, 6.1. Now second line, 2 kg onion means 2x, 4 kg wheat means 4y, 6 kg rice, so 6z will be taking 90 rupees. Yes, it is 90. Now cost of 6 kg onion means 6x, 2 kg wheat 2y and 3 kg rice 3z, and answer is given 70 rupees. And target achieved. What is the price of each item per kg? Represent matrix multiplications. Yes, we express in the matrix multiplication form. So definitely your first matrix, second is equal to 60, 90, 70. It is x, y, z is same as, and after that I will write down here 4, 2, 6, 3, 4, 2 and 2, 6, 3. And now students we represent in the x, a and b forming Now students, I continue my solutions. Here assumptions A, that is x, and here consider B only. So A into x is equal to B. Definitely you will get x is equal to B by. It is A inverse into B. And now I will start my solutions for determinant A only. And then after I decided adjoint and last with product. So determinant A is totally unknown 4, 2, 6, 3, 4, 2 and 2, 6, 3. 4 with minus 3 and the 2. 4 is a 12. 12 minus 12, 0. Next 6, 6 minus 36, minus 30. Again 3 to the 6, 6 minus 36, 6 minus 36 is minus 30. And last 2 to the 4, 4 minus 24, it is minus 20. So 0 plus 90 minus 40, 50, non-zero. So A inverse and a unique solution is exist. So now I will do to adjoint of A. These are the transpose. Students, all cofactors transpose taking in these positions and must be checked. These are in these positions, and these are cofactors. And first cofactors already you written, students, on this here 0, next minus 30, next minus 20. Now these positions are these and that. So 3 3 is a 9, 9 minus 4, it is 5. Next T shapes, L shapes. 4th is a 12, 12 minus 12, 0. And last this one, that and this, 4 to the 8. 8 minus 6 is 18. 8 minus 18, which is minus 10. Now this one, L shapes. See, 6 is 18. 18 minus 8, 10. That one. So this and this, 6 4s are 24. 24 minus 4, it is 20. And last this one, this and that, L shape taking. 16 minus 6, 10. And transpose you know 0, 30, minus 20. Now minus 5, 0, 10, and last 10, minus 20, 10, minus 20 and 10. Now all values, students, I one more time check. 0, minus 30, 20, minus 5, 0, 10, and 10, minus 20, 10. I will do in this part. So A inverse, finally attach that, don't worry. So x is equal to A inverse into B. 1 upon determinant A into adjoint of A into B. So it is xyz. Determinant A is known that it is 50. And adjoint of A also known 0, 30, minus 20. Minus 5, 0, 10. 10, minus 20, 10. And B matrix is this one. 60, 90, 70, and apply matrix multiplication form uniquely. So matrix forming this product with that. So xyz is unique. I write down that here 1 by 50 unique, and that are the product forming. So 0, 9 5 is 45, 450. And plus 700. Next 6 3 is 18, 100, plus 0, minus 7 2 is 1400. And last this and that row, minus 6 2 is 1200. Then after 900, 90 with 10 and 70 with 10, 6 2 is 12, plus 900 plus 700. So finally your done answer 1 by 50. 700 minus 400 means 300, minus 50 means 250. Here 400, and that is a 16, again 400. So it is a 5, 8 and 8, because 0 0 gone, 5s are 8s and 8s are. So price of 1 kg onion is X, 5 rupees. Now continue, price of 1 kg wheat, Y rupees, it is 8 rupees. And last, price of 1 kg rice is Z, 8 rupees. That the students' final answer. I will check my answers. Yes, price to 5, 8 and 8. And here students, our this exercise and happily done here. After the students, you just do itself your miscellaneous examples. Here our this chapter is ending and I will stop this video. Further explanations with the new chapters I will meet you in the next video. Okay, bye bye.